You've seen it happen, right? A cat slips, it tumbles through the air, and then, in this single fluid motion, it's almost like magic, it lands perfectly on its feet. It's a sight so common we barely even think about it, but for well over 100 years, this one simple act has had scientists totally fascinated. Because when you really look at what's going on, what that cat is doing should be completely impossible. I mean, it seems to violate one of the most fundamental rules of the entire universe. So let's dive into this and figure out exactly how our feline friends pull off their famous trick.
So yeah, this ability has a proper scientific name. It's called the cat riding reflex. And the whole paradox, the whole problem it creates, is all about something called angular momentum. And this is where the physics gets really, really cool.
Okay, so the law of conservation of angular momentum basically says this. If an object isn't already spinning when it starts to fall, it can't just start spinning on its own. It needs something to push off of, right? Some kind of external twist or force. But a fallen cat? Well, it has nothing to push off of except thin air. So how in the world does it turn over?
Well, the first major clue to cracking this puzzle is realizing that a cat is not a textbook. It's not a brick. It's not what a physicist would call a rigid body. And that flexibility, that turns out to be everything. And this is really the heart of the solution. A rigid object, like a book, is basically a slave to however it started falling. It just tumbles. But a cat is different. It can actively change its own shape while it's falling. And by just redistributing its own mass, it completely changes the rules of the game.
And they can do this because they have some incredible built-in evolutionary hardware. First, their spine is just exceptionally flexible. Second, they have this tiny unattached collarbone, which gives them this unbelievable shoulder mobility. And third, and this is so cool, they have this highly advanced system in their inner ear that acts like a biological gyroscope, telling the cat which way is down, like, instantly. Okay, so we know cats are flexible. We get it. But how do they actually use that flexibility to flip over? This is where we get into the really elegant two-part move that solves the whole physics problem. Now, before we break down the move, we need one more quick concept: moment of inertia. Just think of a figure skater. You've seen this a million times. When they pull their arms in, they spin way faster, right? When they extend them, they slow down. They're not changing their weight, they're just changing how it's spread out. Pulling their arms in makes it easier for them to rotate. And cats? They do the exact same thing, just in a much, much cleverer way. So, check this out. Here's the brilliant maneuver. The cat basically turns itself into two separate connected bodies. It tucks in its front paws, which makes its front half super easy to rotate, just like that skater pulling her arms in. Now, as that front half twists down, the back half has to rotate a little bit in the other direction. That keeps the total momentum at zero, just like the law says. Then it just reverses the move for its back legs. It's this beautiful, step-by-step solution to a really complex physics problem. It's genius. Of course, getting your body pointed the right way is only half the battle. You still have to survive the landing. And as you've probably guessed by now, cats are evolutionary masters at that part too. And just think about the speed of this. This is not some slow, lazy rotation. This entire complex multi-step maneuver happens in just 0.3 of a second. That's it. All a cat really needs is about a meter or 3 feet of falling distance to completely reorient itself. It's an unbelievably fast reflex. Another huge advantage cats have is a pretty low terminal velocity. That's the maximum speed they can reach when they're falling. Because they're small and have a large surface area for their weight, they top out at around 60 miles per hour. A human, we hit about 120. So right off the bat, the force of impact is way lower for a cat. And when that impact finally comes, they are so ready for it. They splay their limbs out like a little parachute to create more drag, they arch that flexible spine, and they relax their muscles, letting their entire body act as one finely tuned system of shock absorbers. So, what's the big takeaway from all of this? Well, understanding the physics of a falling cat isn't just a fun little piece of trivia. It's actually a masterclass in brilliant biological engineering, and it has some really surprising applications. This might sound like science fiction, but it's true. NASA engineers actually studied the cat's riding reflex. That exact same bend and twist idea, changing a body's shape to change its orientation without anything to push off of, is fundamental to how we control satellites and even how astronauts position themselves in the zero gravity of space. You know, this quote just nails it. It perfectly captures the whole idea. Physics isn't being broken here, it's being absolutely mastered. The cat isn't cheating the rules, it's just so incredibly good at playing the game that to the rest of us, it looks like magic. It's really an amazing example of evolution solving a complex physics problem all on its own. And it kind of makes you wonder, doesn't it? What other everyday miracles are hiding out there in plain sight, just waiting for us to ask the right questions?